Can you tell which of these 3 science experiments is fake? Well, that's your objective in each round of this show. If you're new here, this show is called Two Truths and Trash, and this video is a marathon of all 8 episodes in Season 3, which comes out to a total of 24 rounds. I've already posted marathons of Season 1 and 2, so if you've seen those, let me know in the comments which season you think is the best. For those not new here, the Season 4 premiere is right around the corner, so stay tuned. Anyway, without further ado, here's the full 3rd season of Two Truths and Trash. Enjoy. 2 of the following videos are true while the other one is trash. Can you spot the fake? Round 1, let's begin. If you light a candle and then cut off a small strip from a post-it note to cover part of the speaker on your phone, you can place certain sound waves on your phone, and when you point it at the candle, it extinguishes the flame. If I take 2 identical tuning forks and place them a few inches apart from each other and hit one of them, they both will end up vibrating, meaning even if I stop the one I hit, the sound will continue until I stop both of them. Here it is again while I'm not talking, so you can hopefully hear it this time. If you take some Febreze, spray it on a red apple, and let it soak for about 30 seconds, you can then use a heat gun on the apple, and the heat speeds up the reaction and turns the skin of the apple blue. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. This totally works, and you don't even necessarily have to cover your speaker holes depending on the strength of your speaker, but I found it helps a lot. Oh, and yes, for those wondering, I did add a blowing sound effect to hopefully be tricky. This video was also real. Because both tuning forks have the same natural frequency, the vibration from hitting the first one causes the second one to resonate. Meaning yes, sound will be produced by both of them from just a single hit. That means this video is fake. Spraying Febreze and using a heat gun on a red apple does not turn it blue. It's actually a yellow apple that... No, it doesn't. Here's a quick recap to help you follow before moving on to the next round. Hopefully you got that right, but if not, it's time for round 2. Take a strong magnet and use a compass to figure out its north and south pole and label it accordingly. Then label north on a piece of paper and place a container of water on top. Next, if you place the magnet upright on a piece of styrofoam, no matter what direction you place the magnet boat in the water, the poles of the magnet will always align with Earth's magnetic field, as shown here. You might have heard that you're not supposed to drink water from outdoor rubber hoses, and that's because unlike tap water from your sink, which is a great fire suppressant, once the water runs through a rubber hose, it actually becomes quite flammable, as you can see here. If you have a Ziploc bag that's too large for your snack, you can simply grab a knife, heat it up in the induction heater, and then cut the Ziploc with the hot knife, which reseals it and gives you a smaller bag and some plastic fumes. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Did you think this video was real? Well, nicely done, this was a real way to make a compass. The hot knife does cut through and reseal a Ziploc bag, although I wouldn't recommend it for obvious reasons. If you thought hose water was flammable, you'd be wrong. Before filling the flask with water, I added a small amount of hexane to the flask. Hexane is a clear liquid that is less dense than water, flammable, and doesn't mix in the water. So when I added the hose water and let it settle, the liquid hexane floated to the top. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 3. First up, take 4 straws and connect them to make a square. Then pour some bubble soap into a pan. Next, tie a thin string into a circle. Then dip the straws into the bubble soap and place the string on the film. Now if you pop the bubble film in the center of the string loop, the string will get pulled into a nearly perfect circle. Take a piece of fine steel wool and unravel it so it spreads out a bit and has more access to air. Then roll it back up. After weighing it, you'll see that it's 10.66 grams in mass. Remember that value for later. Next, using a 9-volt battery, light the steel wool and watch as it slowly burns. Wait until it's done burning and then weigh it again. You'll see that the steel wool is now lighter at only 9.49 grams because some of the steel wool burned away. If you need to pour water from one beaker to the other but can't bring them directly over one another, you can solve this by first grabbing some string and wetting it in some water. Then tape one end to the bottom of one beaker and tape the other end to the inside of another beaker. Then fill the first beaker with water, and now you can use the string to pour water from one beaker to the other. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought popping the center of the string would make a perfect circle, you'd be correct. Surface tension pulls the string into this shape, and you can even slide the circle around by tilting it, that is, until it pops, of course. You also can pour water between two beakers using string like this, although unless you're very careful like I was, it's probably going to spill at least a little. If you thought steel wool loses mass when burned, you'd be wrong. Steel wool actually gains mass when it's burned because the combustion draws oxygen from the air to form iron oxide, aka rust, on the steel wool. I made it look like it got lighter simply by not zeroing the scale before measuring it. Here's a quick recap to help you follow before moving on to the next round. Next up, round 4. A steel screwdriver like this isn't a permanent magnet, so it can't attract and pick up small bolts just by touching them. However, if you take a strong neodymium magnet like this and slide the flat side along it in one direction, now it becomes magnetized and the bolt can be picked up. Take an empty ice cube tray and fill 2 cubes up with tap water. Then add several strips of paper towel to one of them and put them in the freezer. When hit with a hammer, the regular ice cube shatters into a bunch of different pieces. However, the ice cube with strips of paper towel will stay almost entirely intact. If you fix one of 2 equal-sized coins in place and roll the second one around it, the second coin will do one full rotation like this before returning to its original position. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. Rubbing a magnet like this can magnetize a steel screwdriver, which helps prevent you from losing small screws and bolts. You can think of the atoms of iron in the steel as little magnets themselves. Normally, they're pointed in all sorts of directions, so it won't act like a magnet, but rubbing the magnet in one direction aligns them. If you thought adding just a few strips of weak paper towel to an ice cube would actually make it this strong, nice job, because you'd be correct. Performing this demo gave me the idea of applying this concept to an ice hammer to see how strong and functional one could be, so check out that video that I'll link in the description if you're interested. That means the coin doesn't rotate exactly once like this, but rather 2 times from our external perspective. Veritasium brought this cool demo to my attention, so check out his much longer video if you want the full explanation. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 5. First up, add some food dye to a plastic bottle with water in it to make it more visible. Place a straw through the cap and seal around the straw with putty. Then screw the cap on tightly. Now blowing into the straw will cause the water level to shoot up. Next, you hopefully remember from last round that you can magnetize a screwdriver by rubbing a magnet on it, but then if you want to demagnetize it for whatever reason, you can simply dip it into water and the polar water molecules will remove the magnetic alignment. First, pour some milk into a bowl. Then grab a scoop of cacao powder and dip it in the milk. You might expect the powder to be wet now, but when you take the spoon out, the powder underneath the surface remains completely dry. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Blowing into the straw does cause the water level to rise once you let go. Blowing air into the bottle increases the pressure inside the bottle, meaning when you take your lips off, water is forced up and out. If you thought this video was real, you'd be right. The cacao powder is mostly hydrophobic, meaning only a thin layer of cacao powder actually gets wet. If I flatten it with a spoon and place it in water instead, the same thing happens. If I make a crater in the spoon and do it again, you can see the water bead and roll off just like with hydrophobic sand. That means you can't demagnetize a screwdriver by putting it in water. The actual way I demagnetized it was by rubbing the magnet on it again, except rotating the magnet on its side like this. This removes the alignment of the iron atoms as discussed before. Here's a quick recap to help you follow before moving on to the next round. Next up, round 6. Frogs are incapable of detecting small changes in temperature, so if you put it in a pot and slowly bring the pot of water to a boil, the frog will die before it detects any danger. The following is the correct order of the size of planets in diameter from smallest to largest. The smallest is Mercury, followed by Mars, Venus, Earth, Neptune, Uranus, Saturn, and Jupiter. Saturn, of course, we're not including the rings. Identical twins have different fingerprints. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. While you pause to think, I wanted to let you know this round came from my 2 Truths and Trash trivia deck, which is a card deck with 50 new rounds of 2 Truths and Trash. It's available for purchase now on my website 2truthtsandtrash.com, and it's a great game to play on road trips with your friends and family. Anyway, it turns out it's a common myth that you can slowly boil a frog without it noticing. The frog would simply jump out once it gets uncomfortably warm. Next up, it's time for round 7. First up, take a plastic water bottle that has some leftover water droplets inside. Then screw on the cap and twist the bottle in half several times to raise the pressure inside the bottle. Now when you go to unscrew the cap will shoot off and a stream of what looks like fog will exit the water bottle. If your friend accidentally puts a permanent marker near your whiteboard and you use it to write on the whiteboard, fear not, because you can just take a dry erase marker and draw over the permanent marker. Now you can erase it like usual and the permanent marker is removed. You might have seen a visual of our solar system like this where all the planets orbit in the same plane. However, in reality they all orbit in completely different planes, most notably with Mars orbiting in a plane almost perpendicular to Earth. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought raising the pressure and then rapidly expanding a plastic water bottle would do something like this, you'd be correct. The sudden drop in pressure and therefore temperature causes water vapor to condense into tiny droplets of visible liquid water. If you actually believed you could draw over permanent marker to remove it from a whiteboard, nice job, because you'd be correct. Because both the Sharpie and the dry erase markers have similar solvents in their ink, the dry erase marker acts to dissolve and therefore overpower the Sharpie's ability to bind to the whiteboard. Side note though, I wouldn't try this on older boards that already have trouble erasing even dry erase ink because it won't work nearly as well. If you thought planets actually orbit in completely different planes, you'd be wrong. All the planets do orbit in roughly the same plane, which is not some crazy coincidence, but rather a result of the way solar systems form. It's too long to get into here, but there's plenty of other videos on this topic if you want to learn more. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 8. First up, place some food dye into a pan of water and stir it. Then take a medium-sized piece of regular printer paper and soak it in the water for about 30 seconds. Next, while the paper is still wet, coat the paper in Febreze and dab it to make it a thin layer. Then lay the paper in sunlight and place something on it that creates a cool pattern. I chose this plant. Let it rest in the sun for about 15 minutes to evaporate the thin layer of Febreze everywhere except under the plant leaves. Lastly, re-soak it in dyed water in the shade. This will remove the dye from where the Febreze still is and dye the rest of the paper darker blue. Now, after letting it dry, you've successfully made a solar print of the object. If you hang 2 balloons from string and then take a heat gun and point it between the 2 balloons, rather than push the balloons apart, the air will pull the balloons towards each other. Next up, take an old film canister and fill it with some water. Then grab an Alka-Seltzer and break it in half. Add the Alka-Seltzer to the film canister, seal it, and then flip it over. After waiting for a bit, the bottom of the film canister will launch into the air. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Blowing air between 2 hanging balloons does pull them towards each other in a similar way to how airfoils produce lift. This one's also real. Dissolving an Alka-Seltzer in water produces carbon dioxide gas, meaning pressure builds inside the canister until it explodes, and here's what it looks like in slow motion. This was not a real way to make a solar print. I swapped out the regular printer paper with specialty solar print paper while you weren't looking. Solar print paper is coated in a photosensitive chemical that becomes insoluble in water when it reacts with light. The area underneath the object does not react with light and therefore is still soluble. So when you soak the paper in water, the dye in the shadow of the object dissolves in the water, making it white. You can make the outlines a lot crisper if you use clear plastic to make the objects as flat as possible, and you just need to soak it in water after, not blue dyed water, before letting it dry. Here's a quick recap to help you follow before moving on to the next round. Next up, round number 9. First up, take a bowl and place it in a pot of water on the stove. Then take a candle and scoop out the wax to melt it down. Then take a regular birthday candle and dip the candle in the wax to provide an additional coating. Then, once the candle is cooled, cut at the wick to expose the wick to the air and shape it into more of a point. The extra layer of wax turns this regular candle into a trick candle, so when you go to blow it out, the candle will relight itself. Fill a bowl with some water and partially submerge a can of electronics duster. Then, after releasing the gas for a while, the can will get cold enough that a layer of ice will form on the can where it was submerged. Take an empty plastic water bottle and drill small holes near the bottom. If you fill it up with water and have the cap screwed on, water won't shoot out of the holes. However, if you unscrew the cap, the water will shoot out until you screw the cap back on, and once again, the water flow stops. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Releasing the gas in a can of electronics duster does cool it enough to form ice. As the pressure is decreased, some of the liquid refrigerant inside the can evaporates, which takes in heat from the surroundings. This is the same principle that your refrigerator uses to cool your food. It's true that the water won't shoot out of the holes when the cap is screwed on. When the cap is unscrewed, atmospheric pressure is acting both down on the water column and on the sides at the holes, meaning it's the weight of the water column that causes the water to flow out. When the cap seals the bottle, though, atmospheric air pressure is no longer acting down on the water column, and the pressure inside the bottle becomes slightly lower as the water tries to leave. This imbalance is enough to prevent the water from shooting out. That means adding an additional layer of wax to the candle does not turn it into a trick candle. A trick candle works because there are magnesium flakes in the candle that can ignite at the lower temperature of the embers, and then it burns hot enough to relight the wick. Here's a quick recap to help you follow before moving on to the next round. Next, it's time for round 10. If you take a bolt and wrap some bare copper wire around it and attach this coil to a battery pack, you've now made an electromagnet, so when you turn it on, you can pick up small objects like this screw. Bring some water to a boil and mix in sugar until the sugar is fully dissolved and it's saturated. Then wet a chopstick and coat it in some additional grains of sugar. Next, add some food dye to a jar and pour the sugar solution in, mixing it. Then take the chopstick and hang it so it's partially submerged in the solution. After leaving the chopstick for a few days, sugar crystals have grown on it and you've successfully made rock candy. When you think of lightning, you probably think of it as striking from the sky to the ground, but lightning can also strike from the ground to the sky. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought this was a real way to make an electromagnet, you'd be wrong. There weren't even batteries in this case. An electromagnet works by sending current through a coil to produce a magnetic field. This copper wire has no insulation, so it just acts like a solid piece of copper, meaning current doesn't travel through the coil, but rather straight across. You'd need to use insulated wire to actually make an electromagnet like this that can pick up small screws and bolts. I just made the bolt magnetic in the first demo using the same magnetizing trick from last episode. That means lightning can strike both up and down, and this was a real way to make rock candy. The hot water allows more sugar to dissolve, and as it cools, the mixture becomes super saturated. The solid grains of sugar on the chopstick provide sites for the sugar to easily solidify on, which grows the sugar crystals into the cool rock candy structure. Here's a quick recap to help you follow before moving on to the next round. Next up, round 11. If you take some steel wool and add some vinegar and then squeeze it out and place it into a jar, the steel wool starts at room temperature, but after a few minutes of reacting with the vinegar in the air, the steel wool has cooled substantially. You might remember from last season that placing 2 polarized lenses perpendicular blocks all light from getting through, and it's a great way to test if sunglasses are polarized. However, if you hold a third polarized lens between the 2 at an angle, now light can make it through all 3 lenses. If you pour a typical bubbly beverage, the bubbles will rise, but if you pour a Guinness into a glass that constricts towards the bottom, the bubbles will go down. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Adding a third polarized lens like this does allow light to go through. If you want to learn why using a cool metaphor treating light as a spring and polarized lenses as slits, I'll link the other video that I made that also explains this cool dark monitor demo. Anyway, Guinness bubbles do go down when poured into glasses that get smaller towards the bottom. There's been a few studies on this if you want to learn more, but basically the upward flow in the center circulates and pushes down the bubbles on the edge of the glass, and the fact that they are smaller nitrogen bubbles rather than larger carbon dioxide bubbles makes them easier to move down. That means this video is fake. Vinegar does react with steel wool and air to cause it to rust more quickly, but this reaction is exothermic, meaning heat is produced and the steel wool actually gets hotter as a result. I just aimed the thermometer at a refrigerated egg to get the lower temperature, and then masked the thermometer in my hand to remove the rest. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 12, a prediction round. Pour some bubble solution into a pan and take 4 straws like this and dip it in to make a thin film with an additional metal straw resting on top. Now if you pop the film on the right side of the metal straw will roll to the right. If you take a popcorn kernel and add it to a hot hair straightener, the hair straightener is hot enough to pop the kernel. If you take 2 Cokes, 1 Diet, and 1 Original and submerge both of them in a container of water, the original Coke will sink to the bottom while the Diet Coke will float to the surface. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that a Diet Coke can floats while a regular Coke doesn't. This difference in weight is mostly due to the difference between having actual sugar versus artificial sugar. Artificial sugars are much sweeter, so you need less of it to make the drink sweet, and by boiling off the water in each, you can easily see the difference in residue left behind. You also can make popcorn with a hair straightener. Popcorn pops when heated because the water inside the kernel evaporates, which raises the pressure. That means popping the soap solution on the right side does not move the straw to the right, but rather to the left. When the film is on both sides of the metal straw, surface tension is pulling equally on both sides and the straw stays in place. Popping the solution breaks the surface tension on that side, meaning the straw will be pulled the opposite way by the remaining film. Surface tension is also the reason that soap can propel a small floating boat like this leaf, and this demo is cool enough that I made a whole separate video taking this principle to its limit on a circular track and a long straight track. So once again, check out that linked video if you're interested. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 13. If you take a piece of paper, fold it into a cone, adding a piece of tape to hold it, and then take a sewing needle and stab it through the cone towards the bottom like this, you can place this needle on a rotating record to play music. First, take some aluminum foil and attach it to a ring on a stand to make a bass tray. Then take some more foil and wrap it around to make a reflective chamber. Next, take a popcorn kernel, soak it in some olive oil, and place it in. Then grab a phone, making sure it's connected to a 5G network, and place the phone upside down, lining up the top of the phone directly toward the reflective chamber. This foil concentrates the signal, which means when you make a call, the waves are strong enough to pop the popcorn kernel. This is a piston cylinder where you can exert force on the piston and air inside the cylinder is compressed. If you take a small piece of cotton and stick it inside the cylinder and then slam your hand on the piston, the cotton will burst into flames. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought simply using paper and a sewing needle would allow you to play music on a record, well, you'd be right. The song wave is encoded physically on the record, and as the needle moves along these grooves, the vibrations are amplified by the paper cone, allowing you to hear the music, although the sound quality isn't great. Placing a small piece of cotton inside this fire syringe and slamming your hand on it also does work. The rapid compression raises the temperature enough to ignite the cotton, and it looks really cool in slow motion. That means you can't pop popcorn by making a phone call like this. I simply added a candle beneath it and let it heat up, which actually popped the kernel. Then I simply overlaid this clip, masking out the surroundings. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 14. This is just a piece of plastic shaped in a non-symmetrical way, such that if you spin it counterclockwise, it spins freely until friction slowly brings it to a stop. But if you spin it clockwise, the plastic will start to rattle, stop, and then spin the opposite direction. If you accidentally highlight something in a book you didn't want to highlight, fear not, because you can just grab a lemon, squeeze some juice out, and then carefully apply some lemon juice to the highlight, and the highlight will no longer be visible. If you take a lit match and bring it near the changing magnetic field of a strong magnet that is attached to a spinning drill, this changing magnetic field is enough to extinguish the flame. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that this piece of plastic is shaped in such a way that it only spins freely in one direction, and it's called a rattleback. You also can use lemon juice to erase highlighter. The dye in the highlighter is sensitive to acidic substances, so the citric acid in the lemon juice fades the highlight. I will say though, this works best with glossier pages and you don't want to add too much. That means spinning a strong magnet with a drill will not extinguish a burning match. I simply added an Alka-Seltzer to a container of water and held the match right above the lip. But of course I removed that container from the original clip. As the Alka-Seltzer dissolves, it releases carbon dioxide which fills up and flows out of the container, which actually extinguished the flame. Here's a quick recap to help you follow before moving on to the next round. Next up, round 15. If you take a bike wheel that's attached to a string like this and drop it, the bike wheel quickly falls. But if you spin the wheel very fast before letting go, the spinning bike wheel stays vertical for quite some time and spins around like this. A regular straw works great for one person, but if you want to make a 2-person straw to share a drink, you can add a Y fitting, and this still allows either person to drink out of their mouthpiece anytime they want. If you take a CD and scratch off the surface to reveal the clear plastic underneath, you can heat this up with a lighter until it starts to melt, and then blow into it to make a plastic bubble. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought spinning a bike wheel allows it to stay upright when dropped, you'd be correct, and this is a great example of the conservation of angular momentum, just like how a toy gyroscope is able to maintain its orientation when it's spun. Of course though, over time it slows down and it will eventually fall. It also is true that you can blow bubbles with the CD. That means you can't simply add a Y fitting to a straw to make it a two-person straw that either person could use anytime. A straw works because sucking creates a pressure imbalance with atmospheric air pressure, so the air pressure pushes the liquid up. Having an alternative route for air to flow into your lungs greatly weakens this pressure difference. Here's a quick recap to help you follow before moving on to the next round. Next, it's time for round 16. First, grab some toy cap gun ammo like this and a match. Carefully remove the paper layer on one of the ammo chambers and place a drop of water inside. Then take the match and carefully but thoroughly dip and spin the match in it. Do so until you see a thin coating on the match. Next, leave this match to dry for a couple of hours. Once it's dry, you can now flick the match and the match will light. If you take some long blocks of ice and add it to enough water, the ice cubes will float, meaning there's some additional water in the form of solid ice above the surface. That means although the water level starts at this line marked with blue tape, over time as the ice melts, the water will rise slightly and end higher than it began. If you take a strong neodymium magnet and attach it to a steel surface, the magnet will stay. But if you place a candle beneath it and wait a few moments, the magnet will weaken and ultimately fall. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that dipping a match in cap gun refill ammo and letting it dry allows you to flick the match to light it, since the powder coating ignites really easily, which then lights the match. It's also true that magnets lose their magnetic strength when they reach hotter temperatures. When these floating ice cubes melt, the water level actually won't rise. Here's what the actual demo looks like, and as you can see, the water level actually stays the same. Since the ice is floating, it displaces an amount of water equal to its weight, which is the same volume of water that it will melt into. I simply added small amounts of water over the course of several hours to make it look like it rose. Here's a quick recap to help you follow before moving on to the next round. Next up, round 17. If you take a 2-liter soda bottle and pour the soda into the glass, you can see that it's highly carbonated. If you leave that soda cap off for a couple weeks until it goes pretty flat, you might think that carbonation is gone forever. However, if you take a pump cap like this, you can repressurize the bottle with air from the surroundings, and after waiting a couple hours, the carbon dioxide in the air once again dissolves in the liquid and you've recarbonated the drink. If you take an M&M and place it in a bowl of water and wait a few minutes, the food coloring starts to dissolve and the letter M will detach and float to the surface, and you can carefully pick it up. You might remember from season 1 that although a metal paperclip is more dense than water and should sink, you can carefully place the paperclips on the surface of the water and surface tension will hold the paperclips up. However, if you take some soap and apply it on your fingers and then dip your fingers in the water gently, the soap causes the paperclips to sink. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that placing M&Ms in water will allow you to remove the M because they aren't water soluble. The letters are pretty fragile though, so you have to be careful when picking them up to keep them intact, and sometimes they don't detach in one piece. It's true that adding soap to water causes floating paper clips to sink. Adding soap to the water greatly decreases the surface tension, meaning it can no longer support the weight of the paper clips. That means using a pump cap like this won't recarbonate your beverage. I simply swapped out the flat soda with some carbonated soda that was at the same level. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 18, a prediction round. If you place a ping pong ball inside a cardboard paper towel roll, leaving a small air gap at the bottom, you can aim a hairdryer up towards the top of the roll like this, and when you turn the hairdryer on, the ping pong ball will fly out. If you measure out the maximum amount of salt you can dissolve in a given container of distilled water, the water level initially appears to rise when you add the salt, because the salt hasn't had time to dissolve. However, salt water is significantly more dense than pure water, so over the next 8 hours, stirring occasionally, the salt water level will actually be lower than the originally marked level of pure water only. If you take a Lazy Susan and a sealed clear tube of water that has an air bubble in it and tape this tube to the center of the Lazy Susan, when you spin it, the air bubble will move to the center. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Aiming a hairdryer like this at a cardboard paper towel roll with a ping pong ball in it does cause the ping pong ball to fly out. Spinning this clear tube with an air bubble does cause the air bubble to move to the center. This is similar to how a helium balloon moves forward in a car when you accelerate, like you saw last season. The heavier water moves towards the outsides of the tube, which pushes the bubble to the center. Although salt water is more dense than distilled water, it would be incorrect to conclude that adding salt to water lowers the water level. You aren't comparing equal masses of each. When the salt is initially added, the water level goes up by the volume of solid salt. Then, as the salt dissolves, the water level does lower, but the final fully dissolved level would still be higher than that of the original of only distilled water. Here's a quick recap to help you follow before moving on to the next round. Next up, round 19. If you take some ivory soap like this and place it in the microwave, the soap will expand as it heats up, creating a hot fluff that looks like this. This is a plumbago shrub. Plumbago is the old-fashioned term for graphite, and that's no coincidence. Taking a segment of the branch and starting to whittle, you begin to see the thin core of graphite. Whittling it down further and then using a sharpener, and now you've successfully made a wood pencil, just like how they made them in the old days. This is a paper beach ball. Air can't permeate through the paper and can only enter or leave through this small hole shown here. If I unfold it slightly and then whack it over and over again, more air enters than leaves with each whack, and so the paper ball slowly inflates over time until it becomes a full ball. There's no special one-way valves, so to deflate it, you can just squeeze the air out of the hole. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that microwaving ivory soap causes it to expand into a hot fluff. Ivory soap has a unique amount of air and it actually floats in water. It's those many tiny air pockets that expand as it heats up. This paper beach ball, which is a Japanese toy, actually does inflate with repeated whacking. The explanation for this is a bit complicated, so I'll put a link to one explanation that I found in the description if you want to learn more. But apparently, even though air does leave with each whack, more air comes in as a result of the reduced pressure after. This is not a plumbago shrub, I made that up, and these branches don't have graphite in them. I simply bought a pencil that looks like a stick on Amazon. Here's a quick recap to help you follow before moving on to the next round. Next up, round 20, a new special round called a blurred round, where I blur a critical scene to make things more difficult. If you take a glass bottle and fill it to just below the neck with water and grip the bottle like this, you can strike the bottle with your hand and the bottom of the glass bottle will break. This weird glass container has multiple different sized tubes, all connected at the bottom. It's a device that shows how a liquid column's height corresponds to the pressure at the bottom of the container. So if you fill it up with water that's been dyed blue and then place it so it's right side up on the table, you can easily see how the height of each water column is the same, regardless of the diameter of each tube. If you place a dollar bill between 2 glass bottles where one is balancing upside down like this, you can quickly pull out the dollar bill without causing the glass bottle to fall. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. It's true that striking a glass bottle like this with your hand can cause it to break, although I don't recommend this for pretty obvious reasons, as you could definitely hurt your hand. The jolt to the bottle causes a partial vacuum at the bottom of the glass bottle, and this reduced pressure causes cavitation. When the vacuum collapses rapidly, this sends a shockwave that breaks the glass. I wasn't able to get it to work with these larger glass bottles, but it did work when I used a rubber mallet. You also can quickly pull a dollar bill out from between 2 glass bottles without the top one falling. And this is a much lower stakes party trick than if you try to do the classic one of pulling a tablecloth from a table, which will probably result in disaster. It turns out this video was fake. The water actually reaches the highest height in the smallest tube and then lowers as the tubes get larger. This demonstrates the effect of capillary action, which is caused by the attraction of the water to the walls and to itself. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 21. If you take a AA battery, you can touch the negative end of the battery to the touchscreen on your phone and it works, just like your finger or a stylus. If you place a Cheerio in a shot glass of water that isn't completely full, the Cheerio sticks to the sides of the shot glass. But if you add some water until the shot glass is completely full and almost spilling out, the Cheerio will move off the wall and end up right in the center every time. If you ignite a lighter at the opening of an empty plastic bottle, the flame propagates as it consumes the trapped oxygen and lurches the bottle forward, just like a mini rocket. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. You actually can use a battery like a stylus, although it isn't exactly comfortable and you could scratch the screen. But this just works because the ends are a conductive metal, not because it's a battery in particular. So even aluminum foil would work, while these cotton socks wouldn't. To make gloves that work with touchscreens, conductive material is often added to the tips. Filling up a skinny glass of water does cause floating objects to move to the center. To better see why, let's look at the classic surface tension experiment of adding drops of water to coins. You can fit a surprising amount of water on the coin without spilling, and you can really see the curve of the water due to surface tension. The highest point of water is in the center, so when a small floating piece is added, it wants to float to the highest point. Adding some food dye to the water to help you see it better, and even if I try to move the speck to the outside, it returns immediately to the center. The same concept applies to the shot glass, but it's less pronounced. I also tried with a larger diameter glass and a floating golf tee, and it still seemed to work pretty well, although this time it took several minutes for the tee to settle toward the center. It turns out lighting a lighter at the opening of an empty water bottle won't cause this giant flame to happen. I actually just poured a few drops of isopropyl alcohol inside the water bottle, swirled it around a bit, and it was this flammable and volatile substance that actually caused the water bottle to move forward. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 22. First up, take a lighter like this and remove the plastic cap. Then grab a pen with ink, cut the tube, and add a small drop of ink to the nozzle of the lighter like this. Now when you light it, the flame appears to levitate by burning pretty far from the lighter, as you can see here, and stays burning as long as you keep holding it down. If you take a small cast iron pan and heat it up to about 150 degrees Celsius or 300 degrees Fahrenheit, and then drop about 1 milliliter of water on it, it takes about 5.5 seconds for the water to completely evaporate. But if you do this again, except this time make the pan much hotter at around 400 degrees Celsius or 750 degrees Fahrenheit, adding the same amount of water will take less time to evaporate since the pan is much hotter, this time taking a little more than 4 seconds. If you take a chicken bone, this one's from a Costco chicken, you see that it's strong and I can't bend it with my fingers. But if you soak it in some vinegar for about a week and then take it out and dry it off, the bone is now bendable. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Did you think this levitating flame trick was fake? Well, nice try, but this is legit and is probably one of my favorite experiments that I've done in this entire series. The ink decreases the size of the nozzle, which means the butane shoots out at a faster speed. Fast enough that the flame doesn't propagate back to the opening like it normally would. It's pretty cool to see this up close, and I can even rotate my hand a bit as long as I keep the flow of butane. And here's what it looks like in slow motion in the dark. Soaking a chicken bone in vinegar for about a week also does make it bendy. That's because the vinegar dissolves the calcium in the bone. That means if you add the same amount of water to a much hotter pan, it actually won't evaporate faster, but rather will take much longer. This is due to the fact that the pan is so hot that the water is held up by a thin layer of water vapor that actually insulates the water from the heat of the pan. This is a demonstration of the Leidenfrost effect, and this water actually took about 2 minutes to fully evaporate. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 23. This is a special nitinol paperclip. Nitinol, which is made of nickel titanium, is special in that it's a shape memory alloy. So if I bend it into a new shape, place it into a bowl, and then use a heat gun to warm it up, after a few seconds it will return to its original shape of being a paperclip. A single AA battery can't turn on a standard light bulb because it can only provide about a third of the current that the light bulb would need. However, if you take 3 AA batteries and put them in parallel, the light bulb will be able to turn on, although it can't achieve full brightness. If you take some hot but not boiling water and suck it up into a syringe that has a valve you can close the syringe, and now once you pull on the syringe, the reduced pressure allows the water to boil, as you can see here. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you actually believe that heating this special nitinol paperclip would return it to its original shape, nice job because you'd be correct. Nitinol is real and does showcase the shape memory effect as you can see here. And reducing the pressure of hot water does allow the water to boil at a lower temperature since the boiling point of water decreases as pressure decreases. For this video, as I touched the batteries to the base of the light bulb, I simply lowered it, which put the light bulb in range of my plasma globe, which as I've shown before, can illuminate fluorescent light bulbs from a distance. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 24. If you take a block of round fluorofoam like this and drop it on an incline, it'll roll down. But if you take a heat gun and aim it towards the top of the foam block, the faster moving warm air causes the foam block to be pulled up the incline. If you take some flour and put it on a plate and try to light it, you'll see that it won't catch on fire. But if you put some in a strainer and sprinkle it onto an open flame, the small dusting of flour can produce large flames like this. First, pour a thin layer of water onto a plate and take a regular black piece of construction paper and submerge it in the water. Then add some clear nail polish to the water, lift the paper out and let it dry, and now the thin layer of clear nail polish creates a rainbow appearance on the surface of the paper like this. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Using a strainer to sprinkle flour onto an open flame can produce large flames like this. The sprinkling of the flour gives it a larger surface area that's exposed to more oxygen, which allows it to combust more easily. A thin layer of clear nail polish on black construction paper also does leave a rainbow-looking finish like this. That means this heat gun doesn't cause the object to roll uphill. I just added some fishing weights inside the foam and carefully positioned it so the weights were up high, meaning when I released it, the added weight falls down and to the right, rolling the foam up the incline. Thanks for watching these past few years, and I hope you've enjoyed. If you want to directly support the making of more episodes, consider buying me a coffee or purchasing my Two Truths and Trash trivia deck. It makes for a great birthday or holiday gift. Speaking of good gifts, you might know that I'm an avid collector of cool science gadgets and toys. I showcase my latest finds each month or so in short videos, and I've made a website called coolsciencefinds.com where you can browse through all my finds. So if you're looking for a gift option for your science-loving family member or friend, check that out or watch my annual gift guide videos to see those products in action. Thanks for your support, and I'll see you in Season 4.